So, what's really stopping an AI from, say, building an entire web app all by itself? Well, the answer is kind of surprising. It's memory. In this explainer, we are going to break down a really clever solution from Anthropic that teaches AI agents to work less like a machine with amnesia and a lot more like a seasoned human engineer. Let's dive in. I want you to imagine something for a second. Picture yourself as a top-tier software developer. But here's the catch. Every single morning when you show up for work, your memory is completely wiped. You have zero recollection of what you did yesterday. You'd have to relearn the entire project every single day. Sounds pretty much impossible, right? Well, that is the exact challenge AI agents are up against with their limited context windows. And that right there, that's the heart of the problem. You see, AI agents are incredibly powerful in short bursts, but they really struggle with any task that's too big to fit into a single session. Every time that context window resets, it is, for all intents and purposes, starting completely fresh. It makes building anything complex over a long period of time incredibly difficult. Now, this isn't just a quirky little issue. It actually has a name, the long-running agent problem. And even with all the clever tricks we have now for managing memory, like context compaction, the most advanced models out there still just fail. You give them a big, high-level prompts like, build me a clone of claude.ai, and they just can't do it. They get lost, they forget the big picture, and eventually the whole project just grinds to a halt. And what's really fascinating is that when they do fail, they tend to fail in two very specific, very predictable ways. It turns out that without the right kind of structure, these super powerful AI coders consistently fall into one of two traps that just completely derail the project. Yeah, and these two failures are really just two sides of the same coin. On one hand, you have the agent that tries to do way too much at once. It gets super ambitious, tries to build the entire app in one go, runs out of memory, and just leaves behind this half-finished, undocumented mess. On the other hand, you have the agent that quits way too early. It sees some code, doesn't grasp the full scope of the project, and just goes, yep, looks done to me. Both are total project killers. So how in the world did Anthropic crack this nut? Well, they did something really smart. They stopped thinking like computer scientists for a minute and started thinking like project managers. They looked at how the best human engineering teams get work done. The big insight wasn't about giving the AI a bigger brain. It was about giving it better work habits. And their solution is this really elegant two-agent system. Think of it like this. First, an initializer agent acts like a senior engineer or a tech lead. It comes in on day one and sets the whole project up for success. It creates the plan, sets up the tools, and writes out a detailed to-do list. Then, for every session after that, a coding agent comes in. This one is like a junior developer who's been assigned a single ticket. It does its one specific job, and then, crucially, leaves really clear notes for the next person. So, what do these clear notes actually look like? And this is where the whole system gets really cool. The agents don't just talk to each other. They rely on a specific set of files, what the researchers call artifacts, to communicate across these memory gaps. Okay, first up, and this is maybe the most important tool, is the feature list JSON file. You can think of this as the project's unbreakable master plan. The initializer agent creates this by breaking down the huge goal into small, concrete features. And notice that little detail. Passes is set to false. By default, nothing is considered done. This one simple thing is what stops the agent from declaring victory way too early. And here's the critical rule that makes it all work. The coding agent is hard-coded with a prompt that tells it not to edit or remove anything from this list. This makes sure the big picture, the full scope of the project, is always respected. It's a fantastic guardrail. And a little inside baseball for you, the researchers chose JSON instead of, say, Markdown, because they found the model was way less likely to accidentally mess up the file structure. Pretty smart. But it's not just about the to-do list. The agent is also taught professional hygiene, how to leave a clean workspace. It commits its code to Git with clear, descriptive messages. It writes a little summary of its work in a progress file. It can even use Git to undo its own mistakes and run automated tests to make sure it didn't just break everything. This is what real developers do, and it makes the whole process so much more efficient and bug-free. This table from the research paper just sums up the whole strategy perfectly. It's so clear. You can see how for every single one of those common failure modes, there's a specific, concrete behavior that either the initializer or the coding agent is designed to do to prevent it. Agent quits too early. The feature list solves that. Agent leaves a buggy mess. Git commits and progress notes solve that. It is just a beautiful, elegant map of problems to process-based solutions. So what does this actually look like when the agent gets to work? Well, at the start of every single session, the coding agent follows this simple, repeatable routine. It's like its morning cup of coffee. First, it figures out where it is. Second, it gets up to speed by reading the Git history and the progress notes. And third, it looks at that master to-do list and picks the next task. Simple, effective, and repeatable. And what's so amazing is that we can actually peek inside the agent's thought process. It starts every session with a really clear intention. I need to get my bearings. It's not just blindly jumping in and writing code. It's actively trying to build a mental model of the project it's just been dropped into. And then it immediately uses the tools it was given. Let me check the Git log, just like a human developer would. This is literally how it cures its own amnesia, by reading the history that the previous agents so carefully left behind for it. And then, finally, before it even thinks about writing new code, it runs tests to make sure the app isn't already broken. Only after it confirms everything's in a good state does it look at the feature list to decide what to build next. This careful, methodical approach, that's the real secret sauce here. So yeah, this is obviously a massive leap forward, but it also opens up some really fascinating questions about what's next. What is the future of these kinds of agentic workflows going to look like? The researchers themselves point to a couple of really exciting directions. First, what if you built a whole team of specialized AIs? You could have one that's an expert tester, another for QA, a third just for cleaning up code. And second, and this is maybe even bigger, how can we take these same principles, structured planning, clear documentation, incremental progress, and apply them to other massive, long-running tasks, things like complex scientific research or detailed financial modeling? The potential here is just enormous. The biggest takeaway here is a real shift in how we think about making AI better. It suggests that the path to more capable AI isn't just about building bigger and bigger models. It's about building smarter processes. By teaching an AI the very best work habits that we humans have developed over decades, we can unlock its ability to tackle problems of a complexity we could barely imagine before. And that leaves us with a pretty exciting question. What will they build for us next?